Very good morning to all of you. We have started unit number 4, that is curve fitting. What we have studied till now in curve fitting? The curve fitting is the process to find the best fit curve for the given set of data. We have also seen that in the scatter diagram there are different points, and on the basis of the points we have to select a curve, okay, and that curve should pass through the maximum number of points. And which method we are using for that? So we are using the method of least squares to find the best fit curve for the given set of data. And as per the method of least squares, the value of E should be minimum. Now what is E? E is the sum of the squares of the residues. So we have to first of all find the residue that is di. Okay, di can be found by yi minus y, square of it and summation of it. So it is known as sum of the squares of residues. To find the best fit curve, the value of E should be minimum and our curve should pass through the maximum number of points. We have studied up to this till now, and we have also studied the fitting of a straight line to the curve with the help of least square method. In this lecture, we are going to study about the fitting of quadratic curve or parabolic curve, then second degree polynomial with the help of method of least squares. So let us start. Okay, first of all we have to write the general equation for the quadratic curve, or we can also call it as parabolic curve. So this is the general equation: y is equal to a plus bx plus cx square. It is also known as second degree polynomial. It is the equation of parabolic curve also. It is the equation of quadratic curve also, right? Okay, if I want to write this equation at xi, so my f of xi will be a plus bxi plus cxi square. How I can find the residue? Residue di is equal to yi minus y. It can be written as yi minus f of xi. Okay, so I can write like this: yi minus in bracket a plus bxi plus cxi whole square. Okay, and my value of E will be sigma I is from 1 to n and the square of this di. So yi minus a minus bxi minus cxi square. Okay, and the square of this. So this is the equation for the sum of the residues E. So to apply the least square method, the value of E should be minimum. Okay, the value of E should be minimum. So in this case, we will be having three equations. For the value of E to be minimum, del E upon del A should be 0, del E upon del B should be 0, and del E upon del C should be 0. So these are my conditions. Let us study this one by one. Let us derive the normal equations one by one. My first case is del E upon del A should be 0. Now what is my del E upon del A? See, this is our E. Sigma I is from 1 to n. yi minus a minus bxi minus cxi square, the whole square. So what will be my del E upon del A? It will be 2 in bracket yi minus a minus bxi minus c into xi square into minus 1, because derivative of a with respect to a. Derivative of a with respect to a is, see here I can write sigma I is from 1 to n yi minus a minus bxi minus cxi square equals to 0. Let us take the summation sign inside. Sigma I is from 1 to n yi minus sigma I is from 1 to n 1 minus b into sigma I is from 1 to n xi minus c into sigma I is from 1 to n xi square equals to 0. So if I simplify this, I can write sigma y is equal to Na plus b sigma x plus c sigma x square. This is my first equation. Okay. We have found with the help of del E upon del A equals to 0. Now let us take the second condition, del E upon del B equal to 0. So what will be my del E upon del B? My del E upon del B will be sigma i's from 1 to n 2 into yi minus a minus b into xi minus c into xi square into minus xi equals to 0. Okay. Let us neglect the constants. So here I can write sigma I is from 1 to n yi xi minus a into xi minus b into xi square minus c into xi cube equal to 0. So taking the summation side inside, a into sigma I is from 1 to n xi plus b into sigma I is from 1 to n xi square plus c into sigma I is from 1 to n xi cube. Okay. So if we write generalized, so it can be written as sigma xy is equal to a sigma x plus b sigma x square plus c sigma x cube. This is my second equation, and we can also derive the third equation by taking del E upon del C equals to 0. So let us solve that. What will be my del E upon del C? So it can be written like this: sigma I is from 1 to n 2 into yi minus a minus b xi minus c xi square into derivative of c xi square with respect to c, that will be minus xi square equals to 0. Neglecting the constant, sigma I is from 1 to n, here I can write yi into xi square minus a into xi square minus b into xi cube minus c into xi raised to 4 equals to 0. Simplifying this, I can get sigma I is from 1 to n yi into xi square is equal to a into sigma I is from 1 to n xi square plus b into sigma I is from 1 to n xi cube plus c into multiplied by sigma I is from 1 to n xi raised to 4. See, if we write the generalized formula, it can be written like this: a into sigma x square, b into sigma x cube plus c into sigma x raised to 4. So this is the third equation. So by solving all these three equations, we can get the three parameters a, b and c, and by placing these three parameters in y is equal to a plus bx plus cx square, we can get the final equation. Okay. So which are the three equations? Let us write that equations. Sigma y is equal to na plus b sigma x plus c sigma x square. Sigma xy equal to a sigma x, b sigma x square, c sigma x cube, and my third equation will be sigma x square y is equal to a into sigma x square plus b into sigma x cube plus c into sigma x raised to 4. So these are the normal equations, and by solving these three equations we can find the value of a, b and c. Okay, let us study one numerical on the basis of this. Okay, here is the given numerical. We have to fit a second degree parabola to the following values. 4 values are given: 1.7, 1.8, 2.3 and 3.2 are the values of y. Okay, how we can solve this? See, first of all, let us write the normal equations. Which are the normal equations? I am writing the normal equation. Sigma y is equal to Na plus b sigma x plus c sigma x square. Sigma xy equal to a sigma x plus b sigma x square plus c sigma x cube. And the third one is sigma x square y is equal to a sigma x square plus b sigma x cube plus c sigma x raised to 4. So we have to find all of these values. See, 1, 2, 3, then 4, 5, 6, 7. Okay. See, we have to find 7 different values. Sigma x, sigma y, sigma x square y, sigma xy, sigma x cube, sigma x raised to 4. So all of these values, so many calculations are required, right? But instead of solving each and everything, we will use shortcut technique in the calculator. Okay, so let us see that. First of all, reset. Okay, then mode, regression mode, then we have to use quadratic equation. So quadratic equation is selected, right? Now we have to enter the values of x and y. Value of x, comma value of y, m plus. First value of x and y, so 1, comma 1.7 m plus. This is the first value of x and y. Then second value of x and y, 2, 1.8 m plus. Then third value 3, 2.3 m plus. 4, 3.2 m plus. See, now there is no need to press anything, just press shift and 1. You will get all values, sigma x square, sigma x, sigma y square, sigma y, sigma x cube, each and every value you can find. Okay, sigma x square, that is 30. Okay, then sigma x 10. Then again shift, then 1, then next value, sigma y square, that is 21.66. Each and every value you can get. You can get each and every value. You can get all the 7 values with the help of this. And there is no need to make a table or anything. You can directly use that values from the calc. Okay, sigma x cube. So all the values we have obtained. Then what is our next step? So you can see all the values. Okay, we have to place all these values and we have to make 3 equations. The 3 equations will be like this. 9 equals to 4a plus 10b plus 30c. Then sigma xy is 25. So 25 equals to 10a plus 30b plus 100c. $80.80 is equal to 30a plus 100b plus 354c. Okay, now you have to solve these 3 equations, and after solving 3 equations you will be getting the value of a, b and c. Okay. See, to solve this we are having one method with us, that is known as Cramer's rule. If you remember Cramer's rule, okay, A is equal to delta 1 by delta, B is equal to delta 2 by delta, and C is equal to delta 3 by delta. How we can get A and how we can get delta? Delta is nothing but determinant. So 4, 10, 30, okay, 10, 30, 100, then 30, 100 and 354. How I can write delta 1? See, in delta 1 the second and third column will be same as the determinant. And you have to place these values in column 1. Okay, so it will be 9, 25 and 80.8. You have to place D1, D2, D3, that is 9, 25 and 80.8 in column 1 for delta 1, in column 2 for delta 2 and in column 3 for delta 3. And by solving all these you can get the equations, you can get the value of A, B and C respectively. Okay, we are having one more trick in which you can solve the whole matrix, you can solve the whole determinant in a single step. By using proper brackets you can solve the whole determinant in one step. Okay, you can see this in this video, how we are finding that. You can see here, see 9 into 30 into 354 minus 100 into 100 bracket complete minus B. Okay, then neglect the second row, neglect the first row, second column. Okay, then write the values in bracket. Okay, then plus A33, then neglect the first row, third column. Okay, so in this way you can find the determinant. Okay, the value is 160, delta 1 is equal to 160. Okay, and by solving all of them you can get the values like this. Solving you can get the value of A, B and C. The value of A will be 160 upon 80, that is 2. The value of B will be minus 0.5. The value of B will be minus 0.5 and the value of C will be 0.2. And by placing all of these values in A plus BX plus CX square, you will get your final answer. Okay. In this way we can solve the numericals on the base of quadratic curve and parabola. You have to use these steps in the calci and Cramer's rule. Cramer's rule is preferred because it is easier than all other methods to solve the 3 unknown equations. We will come back with more numericals of method of least square in the next lecture. Till then, have a good day. Bye bye.